This is 7.4. This is going to be done in two parts. As I've said before, this is where really where it starts to get a little bit more tricky. In a sense that it's not the most impossible thing to understand, but the problem is if you don't understand things from this section and even from last section, it's really going to be difficult moving forward for you. So what we're going to talk about in this section, the very first thing is we're going to talk about reference angles, and reference angles are absolutely the most important thing for you to understand moving forward with trigonometry. If you don't understand reference angles, you're really going to struggle. You absolutely have to understand what a reference angle is. So let's just get right into that. So we've talked a little bit about the unit circle and how it looks. And we talk about how we always start here at 0 degrees and at 0 radians. Well, what happens is when we come up with an angle, if we were to come up with, say, a really easy angle, say 60 degrees. So that means that this is going to be 60 degrees, and that can be obviously changed back and forth between radians and degrees. But the point is that this 60-degree angle is from where we start at 0. We would call this reference angle 60 degrees because that's the angle that is created between this line that was created and where we had started. Okay, well that's really easy because we're in the first quadrant. Well, the question is what happens when we say go to this point right here, and let's say that that is 120 degrees. So from right here to here, we say that's 120 degrees. So that's how we know that we're in the second quadrant, is if we're given 120 degrees. What are we going to do here? Well, what a reference angle is a reference angle is always the angle that is created from the line that is drawn, or from the ray that is drawn down to the x-axis. It always has to be the x-axis. So this reference angle right here, it's not 120 degrees. The reference angle is the angle that's created between the x-axis and the ray that's there. So in this case, if this was 120 degrees, then what we would do is we'd say we know that this right here is 180 degrees, so the amount of degrees that are left in this case is 60 degrees still. So even though it's a 120 degree angle from the beginning, our theta is 120 degrees, our reference angle is still going to be 60 degrees. That's really important. Okay, let's give another example. Let's say we were down in the last quadrant and we wanted to go, say, 330 degrees. So if we're going 330 degrees, there's our ray. Obviously, if we go all the way around, okay, that's where the 330 degrees comes from. But our reference angle, again, has nothing to do necessarily, it has a lot to do with the 330 degrees, but what it really has to do with is what is left. In other words, what would this angle be in between the ray that was created at 330 degrees and what's here? So remember, this is 360 degrees is where we end. So if we've already gone 330 degrees, then this reference angle is going to be 30 degrees. And this is going to become really important for you to be able to identify what your reference angle is. Not necessarily where it is, but what is it? What is your reference angle in degrees or in radians? For the most part, we will use degrees because we're going to use these special right triangles below here. And I want to make sure we recap what these are because this is important. If you have a 30, 60, 90 triangle, opposite of your 30-degree angle of a normal triangle will just be 1. The smallest angle will give you the smallest side. The opposite of your 60-degree angle will always be the square root of 3. And opposite of your right angle, or the hypotenuse, will always be 2. A 30, 60, 90 triangle will always look like this. Just make sure that opposite of 30 is always 1, opposite of 60 is always square root of 3. On the 45, 45, 90 triangle, this is a little bit different. You have two sides that are exactly the same. The two sides that are opposite of the 45-degree angles are always going to be the square root of 2, and then the hypotenuse will still be 2. Sometimes you'll see it called 1, 1 square root of 2, but we're just going to leave it like this. So these are really the only two things, in my opinion, that you need to remember. You need to know what the 30, 60, 90 triangle sides are, and you need to know what the 45, 45, 90 triangle sides are. Because what that enables us to do is it enables us to actually fill in this table down here. because we know that sine is opposite over hypotenuse. So we already talked about in section 7.3 what the sine of 0 would be. That's where we go up to our unit circle. We say, oh, sine is the y value, so the sine of 0 is just going to be 0. The cosine of 0, that's the x value, that's going to be 1. Well, now to figure out the other ones, like the sine of 30, that's where we actually use our right triangle up here. The sine of 30 is going to be 1 over 2. And then we do the cosine of 30. The cosine of 30 is going to be adjacent over hypotenuse, so that's where we get square root of 3 over 2. Then we do the 45. Sine of 45, opposite over hypotenuse, is square root of 2 over 2. And then the same thing with the cosine is adjacent over hypotenuse, which is the same thing. A little mess up there. Square root of 2 over 2 again. Okay, then we do the sine of 60. And if you do the sine of 60, you see it's opposite of 60 is square root of 3 over 2. And then our cosine will be adjacent, which will be 1 over 2. And then we do our sine of 90. Again, sine of 90 using that unit circle from 7.3. That's that vertical line. The y value there is going to be 1. And then the y value, or the x value for the cosine at 90 is going to be 0. And what you should notice is you should see kind of a pattern there. This is right here. That should be square root of 2. You should see a pattern that this goes from 0 to 1/2 to square root of 2 over 2 to the square root of 3 over 2 to 1. This goes from 1 to the square root of 3 over 2. So it kind of goes in reverse order. So this is going to be a table that you probably want to know a little bit. But again, if you don't memorize this table, then all you need to memorize is the special right triangles, because then you can always fill in this table. So what does this mean? Well, all of these are very easy angles to do because they're all angles in between 0 and 90. But what happens when we actually get into angles that are bigger than 90? And that's where this gets a little bit more complicated. And this is where it's very, very, very important for you to understand reference angles, which is what I was saying. So let's first, in this example, figure out what is the sine of 135 degrees. Well, what we're going to do, and this is the way that I do it, is I always start with a coordinate plane. And then I say, okay, where is 135 degrees at? So I go 135 degrees is, say, about right there. And then what I do is I draw a line, and I know that's 135 degrees. So what's going to happen is I'm going to create a right triangle out of this. And I'm going to go straight down to the x-axis. This is where me having to be able to find my reference angle is very important. So I've already gone 135 degrees. I know that this is 180 degrees over here. So how do I figure out my reference angle? In other words, what's left over is just 180 minus 135, which is 45. So what I have is I have a 45 degree angle here, which is a special right triangle. So what I do is I now label my triangle. Now, be very, very careful here. Make sure we label this correctly. This right here is a positive value because it's above the x-axis. So that is absolutely going to be the square root of 2. But down here, because we're on the x-axis, this is not just square root of 2. This actually has to be the negative square root of 2 because we're on the negative side of the y-axis. And then our hypotenuse will always be positive, and that's just 2. So now how do we figure out the sine of 135? Well, it's the sine, so it's going to be opposite over hypotenuse. So the sine of 135 is equal to the square root of 2 over 2. There's our answer. So using the reference angle, that creates a special right triangle that allows us to then use our trig ratios of opposite over hypotenuse or adjacent over hypotenuse, etc., to find what our value is. Okay, let's talk about the cosine of 2 pi over 3. Well, our first step here is figuring out what 2 pi over 3 is as degrees. So 2 pi over 3 converts to 120 degrees. So what I do is I draw my coordinate plane again. I want to go 120 degrees. So there's my 120 degrees. Create my ray and my triangle. Again, if this is 120 degrees, what is left over? Well, again, we know that it's a full 180 degrees to get to here, so we obviously have 60 degrees left over. So now again, let's label our triangle appropriately. Opposite of 60 degrees from the front side of the notes is always square root of 3, and because the y is positive here, we keep it positive. Our x value here will be negative. That's going to be opposite of the 30, so that's negative 1, and then the hypotenuse is 2. So again, now we take our cosine of 2 pi over 3 is going to be equal to adjacent over hypotenuse, so that's going to be negative 1/2. And that's essentially how you're doing all of these. Figure out where the degrees takes you, which quadrant it takes you to, then figure out what the reference angle would be. Remember, reference angle always has to be to the x-axis. It always has to be going to the x-axis. The triangle should always be created. The right angle should be right there on the x-axis, no matter if it's above or if it's below. Okay? So what I want you to do is try these on your own. Okay? Just try them and see what you come up with. See if you can come up with answers. They should be very similar to the answers we've come up with before in the table from before. Just maybe some will be negative or positive, depending on where your reference angle is. So try these on your own separately, put in an answer, and let's see how you do. All right, so for the first one, you should have gotten negative 1/2. What happens is 7 pi over 6 converts to 210 degrees. We take 210 degrees all the way around, which left us with a reference angle of 30 because we went 30 degrees past 180. So we create our triangle. You ended up with the sides of negative 1 because it's below the y-axis over 2. There's where the negative 1 over 2 comes from. For the cosine, you should have gotten the square root of 2 over 2. Again, when you go 315 degrees around, that leaves us with a reference angle of 45 degrees left over to get to the 360. So again, the adjacent side here of the cosine is the positive square root of 2. The hypotenuse is positive 2, so we end up with square root of 2 over 2. Again, hopefully this makes sense. We are going to spend a little bit of time on this because this is really important that we understand this concept. So I will see you in class.